Hello everybody. Today's lesson is multiples of fractions, and we're on lesson 8.2, page 333 of our textbook. So I unlocked the problem today. Jen is making 4 pans of baked ziti. For each pan she needs 2/3 cup cheese. Her measuring cup can scoop 1/3 cup of cheese. How many scoops of cheese does she need for the 4 pans? Alright, so what do we need to know? Well, we need to know how many scoops of cheese does she need for the 4 pans. We need to know that she needs 2/3 cup cheese for 1 pan. We also need to know that she's measuring the cheese using only 1/3 cup measuring cups or scoops. So use a model to write the product of 4 times 2/3 as the product of a whole number and a unit fraction. So remember, let's think of 2/3 as 2 third size parts. Okay, so there's our 2/3. So 2/3 can be written as the sum of 1/3 plus 1/3. And then we can multiply by a whole number to show that repeated addition of 1/3. So 2 times 1/3. Okay, so we're going to take that idea to figure out how many cups she needs for the 4 pans. So if she had 1 pan, she'd need 2/3. If she has 2 pans, she would need another set of 2 1/3s. So now we have this pan plus this pan. So we have 1, 2, 3, 4 thirds. 2 times 2 is 4. So 4 times 1/3, 4 thirds. A third pan, it would be 3 times the 2 cups needed for 1 pan. So we'd have a total of 6 pans, 6 thirds cups. 1, 2, 3, 4, 5, 6. Okay, so these are the 3 pans. A fourth pan, 4 sets of the 2 cups per pan would give me 8. So 8 thirds. So in simplest idea, it would be 4 times the 2/3. So 4 times 2 will give me 8 and 1/3. So she needs 8 third size scoops of cheese for the 4 pans. Okay, some of you might be confused about this 2 here. Well, remember, in other words, you might be looking at here and saying 4 times 2/3. Why don't we just go 4 times 2 is 8? Well, that is what we're doing, right? The 2 written as a whole number here represents that I'm going to need 2 1/3 cups for every pan. So I am multiplying 4 times 2/3. 4 times 2 is 8. Okay, so 8 thirds. What if she decides to make 10 pans? Describe a pattern you could use to find the number of scoops of cheese she would need. Well, 1 pan, she needed 2 times 1/3, 2 thirds. 2 pans, she needed 2 times 2 times 1/3, which was 4 thirds. 3 pans, 3 times 2 times 1/3, which was 6 thirds. 4 pans was 4 times 2 times 1/3, which gave her 8 thirds. So if we look at the numerators, it's going 2, 4, 6, 8. So the numerators increase 2, 4, 6, 8. So it is number of pans times 2. Therefore, 10 pans would be 10 times 2, or 20 thirds. 20 1/3 scoops for the 10 pans. All right, 334. You've learned to write multiples of unit fractions: 1/2, 2/2, 3/2, 4/2, so on. You can also write multiples of non-unit fractions. Non-unit would mean the numerator is not 1. So use a number line to write multiples of 2/5. So the size of the denominator, fifths, that's not going to change. It's just the numerators that we're really increasing them as multiples. So it's really, in a sense, thinking of multiples of 2. So if we have one set of 2/5, we have 2/5. If we have two sets of 2/5, now we're at 4/5. If we have three sets of 2/5, we'd be at 6/5. Four sets of 2/5 would be 8/5. Five sets of 2/5 would be 10/5. So the multiples of 2/5 are 4/5, 6/5, 8/5, 10/5. So again, you notice that the size of the denominator stayed the same, and we're basically looking at the multiples of the numerators: 2, 4, 6, 8, 10, so on. All right, so write 3 times 2/5 equals 6/5. Write 6/5 as a product of a whole number and a unit fraction. Product of a whole number and a unit fraction. Okay, so 3 times 2/5 would be 6/5. So 1 times 1/5, 2 times 1/5, 3 times 1/5, 4 times 1/5, 5 times 1/5, 6 times 1/5. So if we want to write 3 times 2/5 as a whole number and a unit fraction, I would need 6 times 1/5. How many 1/5s? How many 1/5s do we have? We have 6. So 6 times 1/5. Explain how to use repeated addition to write the multiple of a fraction as the product of a whole number and a unit fraction. Okay, so we're going to write the fraction as a sum of unit fractions. Then write the repeated addition So write the number as a sum of unit fractions. Then write the repeated addition as a product of the whole number and the unit fraction. Okay, so write the multiples of 3/8. Well, 1 times 3/8 is just 3/8. Okay, we have one set of 3/8. Two sets of 3/8 would be 6/8. Three sets of 1/8, 3 sets of 3/8, 1, 2, 3 sets would be 9/8. So the multiples of 3/8 are 6/8, 9/8, oh, actually 3/8, 6/8, 9/8. I left off the first one because it says, where are the multiples of 3/8? Well, 3/8 is a multiple of 3/8. 3/8, 6/8, 9/8. List the next 4 multiples of the unit of the fraction. So 3/6, that would be 1 times 3/6. The second multiple would be 2 times 3/6. So if I have 2 sets of 3/6, I'd have 6/6. 3 times 3/6 would be 9/6. 4 sets of 3/6 would be 12/6. And 5 sets of 3/6 would be 15/6. 2/10. 2/10 is 1 times 2/10. So 2 sets of 2/10 would be 4/10. 3 sets of 2/10 would be 6/10. And we start to notice a pattern. But I'm going to go ahead and still write out the counting number and the fraction. 4 times 2/10 is 8/10. And 5 sets of 2/10 would be 10/10. The pattern I was going to refer to as 2, 4, 6, 8, 10, 12, 14. All right, so let's use the number line for these to write the product as a product of a whole number and a unit fraction. All right, so we see that 1 times 3/4 is 3/4. 2 times 3/4 is 6/4. And 3 times 3/4 is 9/4. So we need to write that as the as the product of a whole number and a unit fraction. Okay, so how many 3/4 do you have? When we got to here, we have 9/4. Well, that's 9 sets of 1/4, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 1/4. So 2 times 4/6. Well, there's 1/4. So that's 1 times 4/6. And then another set of 4/6 will put us at 8/6. So how many 1/6 do we have in this problem? 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 1/6. Because we're repeatedly adding 1/6 plus 1/6 plus 1/6 to get the next number. So how many times did I have to add 1/6 to get to 8/6? 8 times. List the next 4 multiples of the fraction. Next 4 multiples of the fraction. Well, let's put fifths in all of these. That's not going to change. 4 times 1 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. And 5 times 4 is 20. 4/5, 8/5, 12/5, 16/5, 20/5. 2/4. Okay, again, the denominator will not change as we find the multiples of these. So 1 times 2/4 is 2/4. 2 times 2/4 is 4/4. 3 times 2/4, 6/4. 4 times 2/4 is 8/4. And 5 times 2/4 is 10/4. Write the product as the product of a whole number and a unit fraction. Okay, so we say that we have 4 sets of 2/8, which gives us 8/8. So how many 8/8 are being repeatedly added? Let me just write that out, just so we can see what we're talking about with the repeated addition. Okay, so to get to 8/8, I have to repeatedly add 1/8. Okay, so 4 times 2/8 basically represents the sum of 8 1/8. So I can write that as a whole number of 8 times the unit fraction 1/8. 3 times 3/5. Well, 3 times 3/5, we notice that it's going to put us out at 9/5. So the size of the unit fraction is 1/5. How many 1/5 do we have? We have 9. Are 6/10 and 6/30 multiples of 3/10? Explain. Well, 6/10 is a multiple of 3/10. 6/30 is not, because the size of the denominator is not the same. Okay? So if I was, well, let's see, 6/10 is a multiple of 3/10, because 3/10 plus 3/10 equals 6/10. But 6/30 is not a multiple of 6/10. I'm sorry, of 3/10. Because there's no way to repeatedly add 3/10 to get 6/30. Okay, so which is greater, 4 times 2/7 or 3 times 3/7? Well, so how many parts do we have total? Here I have 4 sets of 2/7, which would be 8/7. So 4 times 2/7 equals 8/7. And 3 times 3/7 equals 9/7. So which one's greater? 3 sets of 3/7. 3 times 3/7 is greater, because it equals 9/7, which is greater than 4 times 2/7, which equaled 8/7. Page 336, number 12. Josh is watering his plants. He gives each of his 2 plants 3/5 pint of water. His watering can holds 1/5 pint. How many times will he fill his watering can to water both plants? All right, what do we need to find? The question is what we need to find. How many times will he fill his watering can. How many times will he fill his watering can? What information do we need? Well, he has 2 plants. Each plant gets 3/5 pint of water. His watering can holds only 1/5 pint. So he has 2 plants. Each need 3/5 pint of water. His can only holds 1/5 pint. Okay, how can drawing a model help you solve the problem? Well, it's going to help us visualize the problem, right? So you'll be able to see how many fifths will be needed to water the plants. All right, so 2 plants, right? And each plant needs 3/5 water. So I'm going to draw 2 rectangles of 5th size pieces. I'm going to shade in 3/5. So the rectangles represent my plants and the amount of water the plants need. All right. So how much water do my plants need? Well, I have 6/5 water needed. So my can only holds 1/5 pint of water. So how many 1/5 would I need to equal 6/5? I would need 6. Okay, that would be 1 pint, 2 pints, 3 pints. So 3 times I fill up the bucket. 4 times, 5 times, 6 times. 6 times 1/5. He fills his watering can 6 times. He should probably get a bigger pan. Bigger can. Alma is making 3 batches of tortillas. She has 3/4 cup of water to each batch. The measuring cup holds 1/4 cup. How many times must Alma measure 1/4 cup of water to have enough for the tortillas? Shade the model to show your answer. So this is just like the last problem we did. So for these represent batches. So these are the 3 batches of tortillas. 3/4 cup per batch of tortillas. And she has 1/4 cup of water to fill for each batch. So how many times is she going to have to fill the 1/4 cup to get these? So here she needs 3, 6, 9. She's going to fill it 9 times. Okay. So that's it for lesson 8.2. This is a shorter chapter, and so our next time we get together, we will be reviewing for the mid-chapter checkpoint already. So until then, may the numbers always be in your favor.